This is the very first web server, and it sits here in the Information Age Gallery at the Science Museum in London. By 1990, Tim Berners-Lee, now Sir Tim Berners-Lee, had developed the key technologies that make up the web. HTML, hypertext markup language, still used to create websites. HTTP, hypertext transfer protocol, a set of rules for transferring data across the web. And URLs, uniform resource locators, the addresses that tell you where everything is. It's weird how even the phrase World Wide Web seems a bit retro now. It's not even the web, it's just infrastructure in the background that we don't really pay attention to. Saying you looked up something on the World Wide Web is like saying that you drove somewhere on a road. We know how it works. But the technologies that started with this server are still in use today. Behind the scenes, the vast majority of apps that send and receive data are just using the web. They are sending requests to URLs. They are reading data using HTTP. Just because you don't see a web browser doesn't mean that this tech isn't being used. If you want to connect your app to anything outside the phone it's on, you are going to be using the descendants of the stuff that ran on that black box. There is an old, well-worn joke that the cloud is just when you store your information on someone else's computer, and while the line's a bit dated, it still holds some truth. And there are two aspects to this: running your own systems in the cloud and playing nicely with other people's data that's stored there. Sure, you could run your own web server. You could store everything and maintain it yourself. You could know exactly how many new black boxes are being used and exactly where they are. Or you could go to Google Cloud or Amazon Web Services or Microsoft Azure and just have them abstract all those problems away for you. You're not storing on a black box somewhere, at least you don't have to worry about that. You're just sending your data to the cloud and letting someone else handle the worrying physical atoms. There are some advantages to that. Say your app hits the top of an app store's charts. Now, instead of the 1,000 users that you planned for, you've got 100,000. If you're running everything yourself, you are suddenly going to have to deal with ordering a lot more servers, provisioning them, and then getting rid of them once that rush is over. There is a reason that nearly everyone runs on cloud services these days. It's just typing some commands, sort of. And that's just with putting your systems up there. If you're connecting out to the cloud, you can also pull in the data that other people are sharing. There are massive treasure troves of data and functions that apps can access and users support instead of having to write the code themselves. But for as long as people have been storing data in the cloud, there have been occasional outages and problems. In 2017, a huge number of Amazon Web Services systems were taken down by one of their developers, accidentally mistyping a command during a simple routine debugging exercise. Despite all AWS's safety checks and procedures, that error caused an outage that lasted for hours and wreaked havoc across the internet. Everything from small startups to enormous web companies were affected. Medium, Quora, Slack, Expedia, all fell down. The blackout caused hundreds of millions of dollars in losses. And then there's data security. All that information metaphorically floating about out there. Now, I've got some experience with doing all that, and while I reckon I could explain it, it is very, very easy to make one mistake, to be slightly out of date and accidentally leave all your data wide open. Plenty of companies have done it. So let's talk to someone whose experience is a little more recent than mine. For a small team or just one or two people writing an app, what are the very basics they need to know about data security, about making sure someone doesn't come in and pull all their records out of a database?
The very first thing, and in a way, we've won this war, is SSL, so make sure that your website's secure with HTTPS in the URL bar. I think the reason we've won is because browsers now require it, but that wasn't always the case, so I think people who are starting out now have it a lot better than we used to. An app has to communicate somehow. Let's say it's an API that your app is consuming.
API is short for Application Programming Interface, and it is basically a way of having computers access web stuff for you automatically. For example, if you send a tweet, you could go to your app or you could go to twitter.com and type it in and send it. But if you're writing something to do that automatically, if you're writing code, you don't want to tell it to click the mouse or tap the screen and type. You want it to just send the code. So an API is a simplified, code-only way of getting data in or out of Twitter or Spotify or basically any other web service. No fancy graphics, no colors, no images, just plain text that a computer can understand easily. APIs were really fashionable a few years ago. Twitter, Facebook, Instagram, everywhere. They just set up API connections to let people and bots pull data out and put data in without going through their site. And we now realise years later that it probably wasn't a great idea to keep everyone's personal data open to the world and make it really easy for bots to post and analyse things. When you're building an app and you want to access data or tools that are provided by other companies like Google Maps or Spotify or Wikipedia, you're going to be using their APIs and you'll be working them into your app's back-end code. Just don't expect to be able to work with Facebook anytime soon.
Somehow, let's say it's an API that your app is consuming, make sure it's secure, because if you didn't put security on there, like HTTPS, you will find that anybody in the middle can do what's known as a man in the middle, although maybe now we should call it a person in the middle attack, I think.
There is never a good gender-neutral term for that.
I would actually say store as little data as possible. So before thinking about how to encrypt data at rest and things like that, which is also another option at your disposal, what are you needing this data for? Do you need it permanently or just one-off? Like, there's a difference between storing data in a database or having something in a session or memory.
Wait, what do you mean by that?
When someone logs in, right, you want to store their session. A session is like short-lived, but then you can define that to be 30 days. So, you define how short is, and in that time, they're logged in.
But I guess an app on one person's device is not a big target with a lot of data on it, whereas if you've got 100,000 users and passwords and all their details in one server,
yes.
What's the best way to protect something like that?
The first step would be don't have it.
Yeah, yeah, which I absolutely endorse. If you don't have to store the data.
Like design around security, the first thing you start to do is like, what don't you need to store?
But what about the data you absolutely have to have? The stuff that makes your app run?
Yeah.
You talked about encryption at rest.
Yeah, so encryption at rest is basically you have a key, your key is secret, and you use that to encrypt and decrypt. I think there are a bunch of different techniques that you can use with one, having different keys to both do the encryption and decryption, but the basic kind of principle is that if somebody compromised your database, what they would get is a bunch of gibberish. They would get binary data that they would have to try and decrypt. Depending on the encryption algorithm you've used, that might either be basically impossible, nothing's actually impossible, basically impossible, or relatively straightforward. So you want to choose a more secure encryption algorithm. And I meant to do my research.
No, we are deliberately not going to mention it because by the time, when this video goes out, it might be accurate.
We don't want to sort of propose today's best practice. I don't want to sound like pessimistic or too sensational about this, but it is almost at the point where you should assume data will be compromised at some point. It's probably a better mindset than assuming the opposite, which is optimism, but not necessarily realism.
When you're using a company's API, if it's Twitter or Wikipedia or Spotify or anyone, there'll probably come a time when you can't connect to it properly. Maybe you wrote a line of code wrong and you have suddenly made 1,000 requests in a second to them and you've been temporarily banned or rate limited. Or maybe your connection's just flaky and you can't get through right now. You could just keep hammering retry, but that would be rude. And if you've already caused a backup of requests, adding more to that queue isn't going to help. The solution is something called exponential backoff. There are formal definitions for this, proper complicated algorithms, but I'm going to simplify massively. In short, exponential backoff means that you don't immediately try as many times as possible to restart a connection. You try again after, say, 1 second. And if that doesn't work, you try again after 2. Then maybe after 4, then 8, then 16. And after a while, you're only trying every couple of minutes, or maybe you just wait until the user actually pushes a button to tell you to try again themselves. Of course, if you do offer that try again button to the user, they will probably just keep hammering it until it works anyway. Exponential backoff is a safeguard. It helps your app maintain a healthy and polite relationship with the APIs you're using, just in case you end up using them a little too much. If someone wants to make an app or a website that queries Wikidata, what's the good practice? How can they not accidentally cause a problem for you or overload your servers?
It might be a bit of a learning curve to learn all the query language intrinsics, but from that point on, you're basically free to do whatever you want. We are happy if you reuse our data and build something exciting on it. So there is not much of a restriction. Sometimes you will see on commercial services something like API limits. We don't really have that. We really want to provide a service that is free to use for everyone, and go for it and build something on it and use the entirety of Wikidata.
You told me to pull information from Wikipedia.
Yeah.
So I had a look and I found the MediaWiki documentation. So I started there and I found that it's possible using their documentation. They explain how you can make a query to pull in information for nearby pages that have location information embedded in them nearby to whatever location you provide it. So
They've got all that built in. Oh man, I assumed that you would have to like download the entire Wikipedia dump of all the information and like run through with the coordinates you had and do a load of maths. They just do that? That's like 10 lines of code.
I mean, it doesn't work offline at the moment. We'd have to store it if we wanted it offline.
So if we wanted to turn this into something that would work anywhere, we would actually need to download the whole thing and rewrite that.
Potentially, we would have to maybe cache it the first time we pull it in, or I don't know if we would have space on our phone to download the whole of Wikipedia, but...
But we could download the basics. We could get like the extracts from everything. That's maybe a few hundred meg compressed. That's still a lot, isn't it? All right, yeah, this will
As long
work.
as we don't need it offline, this is good for now.
This will work. So what have we learned? Well, first, when you're storing data in the cloud, focus on security. It is almost certainly easier and cheaper to use an existing cloud service and their security than trying to build your own data center. But if you're holding any information about users or your business, you've got to be sure that you're getting that security right. Look up best practice guides that have been posted recently by reputable sources and follow them. Second, use APIs to add functionality to your app. Whether you want to add maps or weather information or facts about your user's location, there's probably an API that can help, but you need to plan how your app calls on those APIs. How much are you going to be using them, and can you afford it? Are there limits on how many times you can call on that API? Using techniques like exponential backoff will protect you from irritating your API provider in the moments when you might be using it a little too much. And finally, the cloud is constantly developing, and you'll have to keep up. The technologies behind cloud storage and APIs are constantly changing, so your app will have to change with the times. Best practices today may not be the same 2 years from now or even 2 weeks from now. You are effectively building your app on other people's computers. So as they change, you will have to change with them. Next time, let's find out if real people can use your app.